Welcome to another lesson of sectoral structures theory. Again, I'll be using the book Sectoral Structures Theory for this lesson. Today we want to define free and bound actions on sectoral structures, and we will see that this is important to define early on because it has a lot of consequences as we move forward. So again, let AN be a sectoral structure of degree n, and we're going to define O of AN as an action on AN. In this context, by action, we mean either a function or a mapping or an operation. We're going to call it action on AN. Now, if you recall, we said that each sectoral structure has a reverse, which is simply changing instead of reading it from the L prime to the S prime end, we read it from the S prime to the L prime end. And we call that the reverse of the sectoral structure. The key concept to keep in mind here is that each sectoral structure and its reverse are really one thing. They are the same object, they're the same mathematical object, we're just reading them or looking at them from different angles. So think of it like a cylinder. If we look at it from a certain angle, it looks like a circle. If we look at it from another angle, it looks like a rectangle, but it's really one object. Now, if the operation O on AN, we're going to say AN plus when we're reading it from the L prime to the S prime. So on AN plus is this equal to the operation on AN minus, we say this is a free action. In other words, if we do an operation on a sectoral structure, and whether we do it on the standard form of the sectoral structure or whether we do it on its reverse, we get the same result. And this is going to be the majority of the things we look at. We're going to say this is a free action. And this will be most of the operations we will see in this book. For example, if we say D of AN gives us the diagonal of the sectoral structure, which means the length of the line segment connecting the L prime and the S prime ends. And we saw this in the prior lesson. We will call this operation D of AN, and this is a mapping from sectoral structures into the real numbers. So if the operation is the length of this diagonal, then it doesn't really matter whether we're looking at the object from the L prime end to the S prime end or vice versa. In other words, D of AN plus is going to be equal to D of AN minus, and we will say this is a free action. And let's look at this example. We have the sectoral structure 2, 1, subscript 3. And we have its reverse, which is 1, 2, subscript 3. If we measure the diagonal for both of these, it will be equal. Therefore, we say that D belongs to F. So F is the set of free actions. Now, let's look at the other option where the operation on AN and the operation on its reverse give us different results. They are not equal. Then we say this is a bound action. So for example, let's look at the operation S of AN is equal to AN continuous with AN minus. So in this case, we will bring a sectoral structure and we will attach it with an alpha joint to its reverse. So for example, let's look at the sectoral structure 3, 1, subscript 4. and we want to attach this continuously to 1 3 subscript 4. So this will give us 3, and then 1 continuous with 1 gives us 2, and then we're going to have the 3 here. So we get 3 2 3 subscript 8. Now let's do it on its reverse. So we will say S of 1 3 subscript 4. This will give us 1 here and the 1 there because we're getting the reverses. And then in the middle we're going to say 3 plus 3 is 6. So we get 1 6 1 subscript 8. Notice that both of these have the same degree and the same order. We will come back to this concept. However, this sectoral structure is not the same as this sectoral structure. They are different objects. So for this reason, we will say that S is a bound action. So S belongs to B. Let's look at an example that may not be very intuitive and try to figure out whether it is a free action or a bound action. So let W of AN equal AN continuous with AN. So here we did AN continuous with the reverse of AN. But here we're going to bring the sectoral structure and we will attach it with an alpha joint to the next sectoral structure, and we want to see what the result is. So let's look at examples. It makes it easier. We'll begin with 2 1, which is really this sectoral structure over there. 2 1 subscript 3. So if we do W of this sectoral structure, we will say 2 1 subscript 3 continuous with 2 1 subscript 3, which gives us 2. And then we say 1 plus 2 is 3, and the 1 stays here. So this gives us 2 3 1 subscript 6. Let's see what happens if we do the reverse. 1 2 subscript 3. We'll say 1 2 subscript 3 continuous with 1 2 subscript 3. It gives us 1. 2 plus 1 is 3, and then we get 2 here. So what do we have? We have 2 1, 2 3 1, and 1 3 2. It looks like we got different results, but wait a second. These are really the same sectoral structure. So this is this geometric object right here, and this is also the same geometric object. We're just reading it in reverse. So really, we got the same sectoral structure. Let's see another example. Let's look at 3 1 1 subscript 5. So basically we will have 3 1, and then we say 1 plus 3 is 4, and then we're going to get 1 1 here. Subscript 10. If we do the reverse, so if we do it for 1 1 3 subscript 5, we're going to get 1 1 4 1 3 subscript 10. They look different at first sight. However, these are both the same sectoral structure, which is this one, read in two different directions. And this is the key concept here. Sectoral structures are geometric objects. So don't think of them as a collection of numbers. These numbers help us visualize these sectoral structures. For this reason, the geometric properties of this object are intrinsic, while the nomenclature can change. So in other words, W, which may have seemed like a bound action at first, is in fact a free action. And this is really a key concept here. As we go forward and we define different operations and different functions on sectoral structure, it's really important to always keep in mind whether this is free or whether it is bound, because it makes a lot of difference to how we understand these two broad categories of operations on sectoral structures.